What is self-balancing robot? This self-balancing robot is a two-wheeled robot that balances vertically using a closed-loop algorithm. This robot is controllable by a smartphone device or a transmitter. Self-balancing robot uses data from the accelerometer and gyroscope to correct its orientation and position. Parts and equipment needed: Arduino Uno. Geared DC motors. L298N motor driver module. MPU 6050. A pair of wheels. 7.4 volt Li-ion battery. Connecting wires. Circuit diagram: the Arduino and the L298N motor driver module is directly powered through the VEN pin and the 1-2 VOLT terminal respectively. The onboard regulator on the Arduino board will convert the input 7.4 volt to 5 VOLT, and the 8 GA IC and MPU 6050 will be powered by it. The DC motors can run from voltage 5 VOLT to 1-2 VOLT. But we will be connecting the 7.4 volt positive wire from battery to 1-2 VOLT input terminal of motor driver module. This will make the motors operate with 7.4 volt. Working principle: self-balancing robot is based on the principle of inverted pendulum, which is a two-wheel vehicle balances itself up in the vertical position with reference to the ground. It consists both hardware and software implementation. Mechanical model based on the state space design of the cart pendulum system. To find its stable inverted position, a generic feedback controller according to the situation we have to control both angle of pendulum and position of cart. Mechanical design consists of two DC gear motor with encoder, one Arduino microcontroller, IMU inertial mass unit, sensor and motor driver as a basic need. IMU sensor, which consists of accelerometer and gyroscope, gives the reference acceleration and angle with respect to ground, vertical, when encoder, which is attached with the motor, gives the speed of the motor. These parameters are taken as the system parameter and determine the external force needed to balance the robot up. It will be prevented from falling by giving acceleration to the wheels according to its inclination from the vertical. If the bot gets tilts by an angle, then in the frame of the wheels, the center of mass of the bot will experience a pseudo-force which will apply a torque opposite to the direction of tilt. Programming the SBR: now we have to program our Arduino Uno board to balance the robot. This is where all the magic happens. The concept behind it is simple. We have to check if the bot is leaning towards the front or towards the back using the MPU 6050, and then if it's leaning towards the front we have to rotate the wheels in forward direction, and if it is leaning towards the back, we have to rotate the wheels in the reverse direction. At the same time we also have to control the speed at which wheels are rotating. If the bot is slightly disoriented from center position, the wheels rotate slowly and the speed increase as it gets more away from the center position. To achieve this logic we use the PID algorithm, which has the center position as set point and the level of disorientation as the output. To know the current position of the bot, we use the MPU 6050, which is a 6-axis accelerometer and gyroscope sensor combined. In order to get a reliable value of position from the sensor we need to use the value of both accelerometer and gyroscope, because the values from accelerometer has noise problems and the values from gyroscope tends to drift with time. So we have to combine both and get the value of yaw, pitch and roll of our robot, of which we will use only the value of yaw. Thank you for watching.